Hi, hello students. Welcome back to India's most comprehensive online learning platform, Byjus Exam Prep. This is Anil Prasad Surumpudi, and in this session, we are going to discuss about the process management. Already in the previous session of the GATE Fundamental series, we discussed about the process management initial things. Now I'm going to take you people furthermore into the topic process management. So, hi, Ravan. Good evening. So let us start straight away about this process management. So to start with, this is Anil Prasad Surumpudi. I do have a 13 plus years of experience in GATE training. For the past 13 plus years, I've been training the students for the GATE exam. I'm a triple PG holder. I did my MS in Information Technology, MBA. I also did my MSc in Mathematics. So let me not waste more time here. And one more announcement. There is an important session coming in your way, which is being taken by Risha Gupta Madam, MTech NIT, who has got 5 years of experience in training the people, also motivating the people towards their careers. And is a workshop, live workshop on 3rd April at 7:30 p.m. coming live in your way. So please do get registered to this very important session so that you will be able to be benefited by this session towards your career. So do not waste this session. Do not let this session go in vain. I request you people to get registered to the session and make most out of this session, which is coming in your right in your way, 3rd April, 7:30 p.m. And there is a scholarship test being conducted by the Byjus Exam Prep. If you give the scholarship test and score good in scholarship test, you will be able to get around 90% off across across the platform on all the courses in Byjus Exam Prep. The date of scholarship test is 14th April, 9 to 9 p.m. And I would like to congratulate for one more time our toppers for this year. We have several ranks under AR10, several more ranks under AR100, and several more ranks under AR1000. Some important ranks are who's Shivam Garg, Rishabh Gupta, Gyan Dhamak, and Gautam Gudimetla, Shasham Jain, and so many who secured their first rank, second rank, third rank, and fourth rank from various streams here. So I heartily congratulate all of my toppers from Byjus Exam Prep. I also wish you people to be same success as these people in your GATE 2025 and 2026. And parallelly, we also are having one Ground Zero series. In Ground Zero series, we have been targeting, we've been focusing on the basics of the students with respect to their subject in their GATE preparation. So let me start straight away the session, operations on processes. Okay, now the thing is, try to understand. In the previous session, in the last session, we discussed about the process management activities of the operating system. What exactly are the process management activities? Process management activities includes first one is creating and deleting processes. Second one is suspending and resuming the processes. Third one, process scheduling. And the fourth one, the process communication. And the fifth one is the process synchronization. Okay, so we discussed in detail about all these process management activities of the operating system. Now in this session, among these process management activities, let us focus on how the operating system will be able to create and deleting the processes. Now first of all, you just need to understand one thing before we start the process management activities. When you switch on the system, when you look at this main memory picture, initially main memory will completely be empty. When you simply switch on the system, initially the main memory will be totally empty. The moment you switch on the system, what exactly is going to happen? Computer system CPU is going to execute one program which is called bootstrap loader. In one of my previous classes, I talked about this bootstrap loader. This bootstrap loader is going to load the operating system kernel into the main memory. Okay, So what exactly is this kernel portion? Kernel portion is the collection of several resources. Kernel portion is just a collection of several resources, and furthermore, kernel portion also contains the important service that are being provided by the operating system to the processes and the users. So a kernel portion you can imagine as a collection of several resources and the services. Now initially the kernel portion will be loaded into the main memory. So which is going to load the kernel portion into the main memory? The first program that is going to get executed by the operating system, which is called bootstrap loader. Hi Kritam. This bootstrap loader, when is executed by the CPU, is gonna load the kernel portion into the main memory. But understand, when the bootstrap loader is executing, it doesn't load total kernel portion. Only the initial portion of the kernel will get transferred from secondary memory. Say this is secondary memory. When the computer system is switched off, your operating system will only be available in the secondary memory. But you switch on the system, initially operating system must get loaded into the main memory. In order to load our operating system into the main memory, the CPU will execute bootstrap loader program. This bootstrap loader will transfer initial portion of the kernel from the secondary memory to the main memory. Right after the initial portion of the kernel has actually been loaded, the operating system is more than capable of transferring the remaining portions from secondary memory to the main memory. So anyhow, right after the bootstrap program executes, after some time, this kernel portion will completely be loaded into the main memory. On the top of the kernel portion, the operating system is going to load, there is something called system programs. Okay, what are the various system programs? System programs meaning the background programs that are needed to be executed when the user programs or operating system programs are executing. For an example, there must be a compiler, there must be a loader, there must be a linker. These programs will automatically execute every time when you execute a program, right, Pritam? You may be executing a C program, but in order to execute a C program, there must be a system program executed. What exactly is the system program executing during your C program execution? Compiler should execute, right? These kind of a program such as compilers, loaders, linkers, interpreters, all these system programs will be loaded into the system program memory. Okay, right on the top of the system programs, there will something be called the application programs. Your application programs will get loaded right on the top of the system programs. On the top of the application programs, your the actual memory space will get created for the user process. This space is allocated for the user. Okay, so understand carefully, the moment you switch on the system, initially CPU is going to execute something called a bootstrap loader. Right on the top of the bootstrap loader, there is something called a system program will get loaded. In the system program portion, what will get loaded? Your system programs, all the system programs such as compilers, loaders, linkers, interpreters gets loaded, and right on the top your application programs such as MS Word, MS PowerPoint or VLC Media Player, whatever the application that you use to perform your day-to-day routines will get loaded on the top of your system programs in the application programs memory. Right on the top, this is the user space. Okay, this is the user space. In this user space, your user program will get loaded. Okay, an empty space will get created to store the user programs. Right after everything has actually been created, the operating system will wait for the user to load a program into the user space. Understand carefully. After creating everything, after creating all these things, every operating system is going to create one root program, create one root process. Okay, for an example, when you take Linux, when you take an example of Linux, right after the Linux loads all these things, kernel portion, system programs, application program, on the top user space gets created. After all these things, this Linux operating system is going to create a process which is called a root process. The name of the root process is init. Linux operating system is going to create the root process. The root process of the Linux operating system is the init process. more about this init process, how we are going to understand this, how Linux is going to create the other process we are going to discuss in some time. So before that, let us understand this. First of all, we are in this session we are going to discuss only about the process creation, process deletion operations performed by the operating system. Now let us discuss about when a process is about to get executed. First of all, operating system needs to create a process, which comes on the process creation. After process has been created, the process will execute for some time. When a process has been created, a task will be assigned to the process to perform. Right after that process completely executes, that process will finish its execution. Right after process finishes its execution, it must get terminated. So operating system must also make sure that it terminates this process. Okay, so all the other details with respect to the process creation and deletion we are going to discuss right now. Okay, how the process creation is going to happen, let us have a look at. First of all, if you ever want to create, meaning operating system, if ever any operating system want to create a process, first of all there must be a parent process. Okay, a parent process only can create a child process. Again, child process can create one more process. So initially, as I already told you, right after Unix operating system creates the root process such as init, this init will in tandem create many other processes. Okay, these processes are the operating system core process which are used to initialize the system. So initially the root process that is going to get created is init. This init in tandem is going to create some child process. Each of these child process will create some more process which is going to create a tree of the processes. All these processes initially that are created by the init process are called initialization processes, which are required to initialize the system aspects and the operating system aspects. Right after all these processes, the tree of the process have been created, then the system will wait for the user process to be created. Whenever a user wants to execute a program, the operating system will create corresponding process to execute that user's process. Okay, so understand this. Let us understand the details of the process creation. If at all a process has to get executed, first of all there must be a parent process. The grandparent process, the Adam process, what would we call as the Adam process or the grandparent process for the Unix operating system is INIT, init process. Okay, now parent process create children process, which in turn create other process, forming a tree of process, as I already told you here. Generally, process identified and managed via process identifier. Every time when a process has been created, a PID, process ID, which is pretty much unique, will be assigned to a process. Let us say I'm a process, I just am created. The moment I'm created, operating system will assign an ID to me. Understand carefully here one more important thing. Let us say a parent process. I would say the parent process PXYZ. Okay, during the execution it creates a child process P. Now when the child process P has been created, an identifier should be assigned to the child process. That identifier is ABC. But understand carefully, the actual parent process identifier XYZ will automatically be attributed to the child process also. Child process PID is by default his parent's process ID, parent process PID. In addition to which, child process also will have its own PID. It is similar to whenever you born, you will be assigned with a name, you will be given a name, but before that name, you are going to be attributed with your father's name, right? Okay, similarly, here in the operating system also, whenever a new process being created, one PID will be assigned. PID is basically a number. In addition to which, this PID will also contain his parent's process PID. So the parent process PID will automatically be assigned to any child process PID. Okay, so that's it. Now the next thing, the next important that is to be discussed is understand carefully. Every time when a process is created, when a process, let us say process been created. Why this process created? And what is the requirement for this process? And what is actually needed by this process? Let us understand. When a process actually has been created, any process requires, for an example, this is a child process. A child process just has been created right now. This child process requires initially something called the resources. Okay. Whenever a process has been created, the child process has been newly created, requires some resources. What are the resources? Resources are very simple. The first one is CPU time. Second one is memory space. And the third one is, IO devices. Fourth one is some files. Any process, when created, they require certain set of resources such as CPU time. Every process during the execution, it requires some CPU time, right? So obviously, every process when created, it asks for some CPU's time. Right then, it also asks for some memory space to reside. Right then, it asks for the IO devices during the execution. Some process may want to print something on the monitor. Some process wants to use the printer. Some process needs, the inputs from the keyboard. Some process needs the inputs from the mouse. So any process during the execution may require a certain set of IO devices. So obviously, the process will also ask for IO devices. Obviously, every process during the execution may use some files from the file system of the operating system. So initially, first of all, we need to understand during the process creation, when a child process been created, child process requires a certain set of resources. Okay. In addition to these various physical and logical resources, any process, any child process during the creation may also need some initialization data. I discussed about the initialization data in the last class. Just do refer to my last class, do access my last class, watch my last class, in which I completely talked about the initialization data which is needed by any process during its creation. So now we will only talk about a resource, okay, required by the process. Now after the resources have been allocated, any process requires some job to do. Okay, I just am created, you are created. What is the purpose of your creation? You have actually arrived here on this globe for a purpose. Right after you fulfill the purpose, you may leave this. Similarly, the process which has been created by the operating system requires to perform a task. So the moment the process has been created, the process also needs a job to perform. Okay, right then, the third thing, understand, the moment any process has been created, after you attribute the resources and a job to it, it also needs some execution sequence. Let us discuss about the execution sequence in some time. Okay, when you need to perform your job, I hope you got a point. You are given a job. Let us say your job is to print something on the screen. Okay, that is your job. During the process creation, you've been created and you've been given with the resources. Now you have already been assigned with a job. Right then, when you have to execute, when you need to perform your task, you also need this, because it is not only you in the system, there are several other processes also in the system. Definitely you require some time during which you are going to perform your task. Okay, so you will require all these things. Okay, so now the thing is, the first question, how the resources will be given to a process? How the resources will be attributed to a process? Let us understand. When you just have been created and asking for the resources, any operating system will have two ways to give the resources that you actually require. The first thing is, operating system itself is responsible for providing the resources to any child process that's been created. For an example, I am the operating system. There has actually been a child process created. Now it is my duty to assign the resources to the child process. This is the first scenario of attributing the resources or assigning the resources to the child process that's been created. Nowadays, this approach is not being used by any of the operating system at all. Why? I'm going to discuss in some time. The next thing is, When a process is created, obviously there will be a parent process that creates this child process, right? For an example, Px created Py. What is the parent process of Py? Px is the parent process of Py, right? So when Py is created, when it asks for the resources, it is the responsibility of the Px to provide the resources to the child process. Now this approach only is being used by the modern operating system because, hello Anu, good evening. I hope it's a long time. How you guys are doing? Okay. Yeah, fine. Px and Py. When Px is the parent process, Px needs to attribute the resources to the Py, because if the operating system takes the responsibility of attributing the resources or assigning the resources, definitely the system resources will be exhausted sooner. There will not be any practical restriction on the number of processes that's been created by any process. For an example, I am a process. I want to create some child processes. Here the thing is, if operating system gives me some guarantee that it is going to assign the resources to all the child process, obviously I can create as many child process as I need, right? So obviously at some point operating system exhausts with all the resources, right? Am I correct, Anu? Okay, so that approach is not being followed by any of the operating systems right now. Only the parent process that is creating the child process also is responsible for assigning the resources to the child process. So the first question is done. So here is parent and child share the resources. When I create some child process, I need to make sure that the resources that are with me are shared among my child. That's it. Okay, and the second option should be ruled out because the third option should be ruled out because a parent and child share no resources. This should not be the option, because when the parent and child share no resources, operating system needs to attribute the resources, assign the resources to child process, right? So this approach is not being taken. So only the first two approaches, in which parent process allows. Great. That's nice to see you back. Follow the classes. Fine. Hope you all guys, my previous students, are doing really great. Fine. Let me get into the session. Now, next thing is the execution options. How parent process and child process executes together right after the child process has been created. There are two approaches for this. The first approach is parent and children execute concurrently. Concurrently meaning parallelly. Parent executes as well as child also executes. Okay. When I create a child process, I will do my job, she will do her job. Okay, that is one way. And the second way is parent waits until children terminates. That is, understand carefully. I just have created one process. There is a child process. Let us say I'm a parent process, Anu is my child process. Okay. Now the moment Anu has been created, what I will do is I will wait till Anu completely gets executed. Okay, so this is the second scenario in which when a process has been created, when I create a process, there is a purpose why I created a process, right? I gave a job. The job must be performed by my child process being created. Now, before my child process completely executes and terminates, what I will do, I will wait. I will not execute at all anymore. So let us completely discuss about these scenarios, how these scenarios will be carried out in the operating system by taking one example operating system, which is Linux. We're going to go to the case study of the Linux. Now have a look at this. This is what a case study of the Linux. In the Linux operating system, the moment the operating system has completely been loaded, then my Linux operating system is going to create one root process which is called init. Next thing is this init process in tandem will create several child processes. Each of the child process creates another process. Okay, finally a tree of process will get created. All these tree of process are going to be used only to initialize the system. Right after this tree of the process, which are operating system process have been created, and this operating system will need to wait for the user to load his programs into the main memory. Right after his programs are loaded into the main memory, to execute those programs, operating system will create several other processes. This is the scenario. Okay. address space, as I already told you. The thing is, whenever a process, let us say this is my main memory. Okay, in the main memory, there is a process. Okay, there's the process panel. Okay, the panel has been created. Right after panel is wants to create a child process. It created one child process called pxyz. Okay, when this pxyz created, first of all, pxyz also needs to be stored somewhere, right? Where exactly it is going to get stored? There is no other way. This pxyz must also be stored in the same location as the parent process. Have you got a point? Right? Am I correct? Of course I am. Okay. Now, child has a program loaded into it, meaning child needs to perform some job here. Now you understand this. I'll talk about this fork system call in a while. Let us understand this. See, first of all, any process, for an example, panel is the process. When executing, it needs to create a child process. In order to create a new child process, am I audible and visible? Could you please respond? Anu, Hritam, Ravan? This is completely all right. Are you experiencing any technical glitches? Okay, this parent process needs to execute one system call, which is called a fork system call. What is a system call? System call is an operating system internal function. In the simplest words, system call is a function, a small task, which is written in the operating system's kernel. Okay, so when fork system call has been called by the panel's process, this fork system call will create a child process. I hope you got a point. Okay, this fork system call will create a child process. This is a Unix example. Okay, but for when it comes to Windows operating system create new process. Okay, NT create new process, something like this, forgot right now. But when it comes to the Unix system call is fork. When fork system call is being called by Anil process, immediately it is going to create a new child process. Okay, now understand carefully. Just let me, all of you, understand carefully. Now the thing is, this is Anil. Okay, this Anil is forking one process. When he's forking a process, a child process gets created. Okay, when child process gets created, it will execute one system call which is called exec. I'm just going to explain in a short while how exactly this is going to happen. Right after child process completely executes, it is going to execute one system call which is called exit. By executing the exit system call, the child process will completely terminate. The moment child process terminates, my the parent process, which is Anil, will resume. Understand carefully. Anil created a child process. That child process will execute. For this, it is going to execute one system call called exec. I will tell you how exactly this works in a short while. Right after that, right after completely executes, it is going to execute one system call which is called exit system call. Meanwhile, what Anil is doing? Anil is not doing anything. He's been waiting. Did you get me? He's been waiting. Why he's waiting? He's waiting for the child that's been created to get terminated. Once after his child terminates, he is going to resume. I hope you got the point. But how exactly this is going to happen? I'm going to tell you right now. See, this is a C program. Just have a look at the C program, you'll understand. But I will give you the complete scenario. Where is this? I just need some space here. Okay, I will erase this. Now understand. When a fork system call executes, this fork system call may have three possible outcomes. This fork system call may return a negative value. This fork system call may return a zero value. This fork system call may return a positive value. What is it with this -1, 0 and 1? Okay, let us talk clearly about this. Okay, when fork system call returns a negative value, that means child creation is failed. Child has not been created. Child creation completely is failed. It's a failure. Okay, but whenever fork returns either 0 or 1, that means child creation is successful. But what is this difference? What is the difference between 0 and 1? Whenever fork returns 0, what is the outcome? Whenever fork returns 1, what is the outcome? Let us have a look at this. For both these cases, we can say that a child has been created. A child process has been created. But how it's going to work? Let us have a look at. When the fork returns 0, obviously let us say this is CPU, okay? This is CPU. Now in the CPU, the parent process, P Anil, is executing right now. Okay, now during the execution, it calls fork system call. When the fork system call is executed and the return value is 0, fork system call returns 0. Obviously, child has been created. Child creation is successful. But what is it with the 0? When fork system call execute and returns 0, that means child has been created and child is right now executing in the CPU, sending the parent back to the main memory. I hope you got the point. When fork system call returns 0, child creation is successful and within the CPU, child is executing, not the parent. Parent has actually been sent back to the main memory. Now within the CPU, which process is executing? The process which has been created as a child process is executing. P child is executing. Now when the fork returns 1, what is the outcome? Whenever fork returns 1, of course child process is created, but still the parent is continuing in the CPU. It is not the child that is executing. When fork returns 1, child process has been created and parent is still executing in the CPU. I hope you completely got the point. Did you? I hope you did. Okay, now the thing is, you need to understand. When the fork system call execute, I'll tell you the scenario right here itself. I'll explain, describe the complete scenario over here itself. Okay, now when fork returns 0, what does it mean? Child is created, child is now executing right now. Okay, the moment child started its execution, the first step of the child is to execute one system call called EXEC. When a child is created, the first thing that is going to be performed by the child process is to execute an EXEC system call. This EXEC system call will allow the child process to use the memory space of its own parent. I will tell you, let us say this is the main memory. Let us say this is the main memory. Okay, in the main memory, there is a space for the parent. This is the space for the parent. When a child process is created, initially child is going to execute one system call called EXEC. This EXEC system call allows the child process to use the address space or the memory space of its parent. So what will happen? This EXEC system call will allow the child process to use the same memory space of its parent. Okay, right, then what is needed? What is more needed? Nothing else is needed, because within the parent's memory space, child process is now right now loaded. Where is the parent process right now? You don't need to worry about a parent process. Parent process actually available in its own PCB, process control block. Okay, when the child process is loaded, it will continue. Okay, the moment it is going ahead, at some point child process will completely finish. When it completely finish, it is going to execute some system call called EXIT. What is EXIT? Exit system call. This exit system call will request the operating system to terminate the child process. That the moment child process has been terminated, immediately what is going to happen? It allow the parent process to resume. Meanwhile, I'll tell you the different scenario with the parent. The parent, when it is executing, when it returned 1, what does it mean? Child process is created, but still the parent is executing, right? Okay, so when the parent is executing, what the initial step of the parent is to execute the wait system call as shown here. Okay, I'm the parent, I still am executing, although my child has been created. I don't need to execute, because when the child is created for a purpose. Until and unless the purpose is fulfilled, I do not want to execute anymore. So the first step of myself is to execute a wait system call. What is wait system call? The wait system call will send the process that initiated it into a waiting state. For an example, I executed a wait system call. This wait system call will send me to a waiting state. If I am sent to the waiting state, I will not be considered for the execution anymore. Okay, so the operating system, when a wait system call is executed, this wait system call will go to the parent's process PCB. In the parent's process PCB, there is something called, just a minute, there is a specific field called status or state. The state will be changed from running to waiting. Whenever any process state is waiting, this process will not be considered for the execution. So understand carefully, whenever any process calls a wait system call, this wait system call will directly go to the PC of the process which called it and change the state from running to waiting state. If a state is in the waiting state, the operating system will not consider this process for execution anymore. When this will change from waiting to ready again, whenever the child process has been created, terminated by calling an exit system call. Okay, whenever an exit system call is as you can see, whenever an exit system call has been executed, that exit system call is going to completely terminate the current process that called it. Right after the exit system call is executed, exit system call is going to send a return value. That return value of the exit system call will pass as a parameter to the wait system call. Then the parent process will resume. I hope you completely got the point. Okay, I hope, did you understand this? I guess you did. Okay, this is all about process creation and process deletion. How the processes will get terminated. Okay, what are the different kinds of terminations we do have? We're going to discuss in the next session. Are we clear so far? Okay, I will show you the C program here. I'll show you the C program here. Now, this is the parent process. The parent process, actually you can see here, parent process calling a fork system call. This fork system call, yeah, sure. Yeah, understand this. Fork returns 1, right? Your question is? Whenever fork returns 1, you can see this is my CPU, okay? In the CPU, there's a parent process. This parent process calls fork system call. When the fork system call returns 1, child process been created. Although the child process created, still within the CPU, parent process running. Okay, if it returns 0, obviously child is created, but child is executing in the CPU. So that is the difference. For example, I'm a parent, you're a child. Kritam has been created. Okay, when the fork returns 0, I will go to the CPU, you will enter into the CPU for execution. You are created and already started your execution. But fork returns 1, meaning child has been created, but parent is still executing within the CPU. If the parent is still executing within the CPU, parent needs to execute some system call which is called a wait system call. You can see here. Okay, I will show you this help of the C program. Now understand this. Fork is called and the fork value has been transferred to something called a PID. So the return value of the fork will be transferred to the PID. Okay, if PID is less than 0, obviously that means what? If the PID is less than 0, child has not been created. Child creation has been failure. Otherwise, if the PID is equal to 0, obviously child process created and child process executing. When the child process is executing, the first step of the child process to execute EXEC system call. Okay, EXECLP is the flavor of the EXEC system call, only what we discussed a short while ago. But whenever parent, this PID is equal to 1, you can see this else part says that if the PID is equal to 1, Whenever PID is equal to 1, what is that? Parent is still executing. When the parent is executing, what it needs to do? It needs to execute a wait system call. I hope you got the point. Did you? Are we completely done? Yes or no? Pritam, Anu, do you have any more doubts? Okay, then if you don't have any more doubts, we're just going to leave here, and in the next session we're going to discuss about what are the various ways of termination of with respect to a process. Okay, so till then stay tuned, and yep, the vision courses have been started. Many sessions are ongoing, and there are upcoming batches also for the GATE 2025 and 2026. We are aspiring GATE 25 and 2026 to get registered to the Byjus exam prep and get a package of the live classes, recorded lectures, study material, practice quizzes, and mock tests and whatnot. You'll get a certain set of tools or whatever you call, which are pretty much helpful for you to crack the GATE exam 2025 and 2026. Okay, so if you do have any counseling, just do give a call to this number which is on the screen right now, and you will get a one-to-one counseling. Also, you can fill the counseling form right available in the very description box. Till then, thank you so much. Anil Prasad Sorampudi signing off, and good night.